Hi there. In this video I want to show you how to simplify so that there are no negative exponents. So this is an example. Here we have x to the power of 5, w to the power of negative 8. This term is divided, or these factors are divided by 4, y to the power of negative 7, z to the power of 6. So what I like to do is I like to first just take all the constant numbers. Notice you can only do this if there is only a single term in the numerator and a single term in the denominator, meaning that we only working with one term as a whole, but basically that we only have factors in our expression. So what we have is 1 divided by 4, so I can start with 1 divided by 4. That's the only constants that we have. Then I like to write down all of my unknown values. I've got an x. Let's even do it alphabetically, why not? We've got w, x, y, and z. After that, I would look at all the exponents and add up exponents that are in the numerator and subtract exponents that's in the denominator. So what I have in the numerator for x, so for w, I have in the numerator just a negative 8 exponent. For x in the numerator, I have a 5. For y in the I have a y in the denominator. So notice what I said. In the denominator, I subtracted. In the denominator, I subtract. So I don't have a negative 7 here. I have a negative 7. That gives me positive 7. After that, I take the z. And again, I subtract the exponents. There's only a z in the denominator, so I subtract it. That's negative 6. After I've done that, I can write my whole thing again as a fraction. I look at my constants. I've got a 1 in the numerator, so there'd be a 1. Sometimes not necessary to write it if there were other things. And there's a 4 in the denominator. Now everything with positive exponents will come in the numerator, everything with negative exponents will be in the denominator, and they will be positive again. So in other words, we'll have x to the power of 5 and y to the power of 7. In the denominator, everything with negative exponents, but they'll now be positive. So w to the power of 8 and z to the power of 6. Okay, so I want to show you, this is a simple method, and I follow this method every time, especially in complicated expressions. But what I want to show you from this question, or from the original question to the final answer, a quick method that you could have done. What you could have done is you could have just swapped anything with a negative exponent. If it was in the numerator, you could move it to the denominator. So look, there's w to the power of negative 8. It could move to the denominator as w to the power of 8. Y to the power of negative 7 in the denominator moved to the numerator as y to the power of positive 7. Okay, so that is one way of doing it, but again, this you can only do if you don't have pluses and minuses. In other words, you don't have more than one term, either in the numerator or in the denominator. Let's look at one more example. Here we have 8 in the numerator, a to the power of 2, b to the power of negative 3, d, that would be to the power of 1, 2 in the denominator, as well as s to the power of negative 1, t to the power of 4, and u to the power of negative 3. So again, I'll do my foolproof method. That will definitely work, and I don't have to take shortcuts. But 8 divided by 2, in other words, I first take my constants. 8 divided by 2 is just 4. Then I write down all of my unknown factors as in alphabetic order. And I write their exponents. If the exponent is in the numerator, I keep it just as it is. If the exponent is in the denominator, I subtract it. So a to the power of 2, b to the power of negative 3, and d to the power of 1. Then in the denominator, I subtract it. Basically, in this case, all of their signs change. So this is s to the power of negative 1, which gives me positive 1. T to the power of negative 4, and u to the power of, and then negative 3 would be positive 3. And then I go and write it as a fraction again, anything with positive exponents in the numerator and everything with negative exponents in the denominator, because negative exponents means I am dividing. So we've got 4 a to the power of 2 d s and u to the power of 3. In the denominator, everything with negative exponents, but now once I divide, I should take away the negative. Okay, t to the power of 4. And now once again, you can see that b moved to the denominator, s and u moved to the numerator, and the exponents became positive. So that is a quick, also foolproof way of doing this, but this one will be more relevant a little bit later when we actually have more than one factor. We'll see you in that video.